All right, welcome back, everybody. So, picking up where we left off, we've got the management connectivity from router 1 to switch 1 down to switch 2, and we're ready to now establish some connectivity up to, the outside world, if you will. For simplicity's sake, I've decided that, I want to make the focus on this right now, but branch site to branch site connectivity and some of the internal mechanisms that we're playing with inside the sites themselves. So we're going to make less of an emphasis on the routing between the sites for the moment, and later on we'll start introducing some more cool stuff like routing protocols. We can use any of them, right? So for now, we're just going to do some simple static routes up to this node to be able to have reachability over to site B when we're ready for that. So, and we'll introduce something else too here in a second. So router 1, let's go to router 1. And let's go ahead and configure E01. So, we'll just kind of pretend this is an ISP, some kind of an internet service provider or what have you. They, we called them, we said, hey, we need a connection for our site A, and we want, 1 gig circuit to the internet, and they provide us the IP information. So typically this is something that they'll provide to you if you want a static IP as opposed to a DHCP address. And let's just pretend I typically use 200 dot something for my labs. So what we'll do is we'll go into E01. We'll say description. We'll say ISP 1 gig internet. All right. Wherever you are in the world, that's going to change ISP wise. So that's fine. We'll say IP address is 200.1. Actually, 200.0.1 for site A. This doesn't really matter. I'm just overthinking it. And we'll make us.2. This time we'll use a /30 to make it a bit more real life or realistic. So a /30 or a /31 are the two subnets you'll typically see with ISPs or WAN connectivity because they want to preserve the amount of IPs that they hand out to their customers. So in this particular case, just knowing subnetting off the top of my head, I'm using .2. The only other available IP in this block is going to be .1, which I'm planning on assigning to the ISP themselves. So we'll go ahead and we'll throw that on there. We'll do a no shut for good measure. And let's just do show run interface E01. We can see that we assigned a description, we gave it an IP address, and we should see that the interface is up, which it is. So that's good. Now, the only other thing we're going to do for the moment is we're going to create a basic default static route that points all of our traffic to this ISP. So to do that, we do IP route, and typically it wants the destination, then the subnet mask, and then the next hop. So a default static route is going to engulf basically everything. And to do that, it's all zeros, okay? Then it wants the subnet mask. For a default static, again, that's all zeros. So that's just saying, hey, any traffic that's destined for something, send out this route, essentially. Now it wants the next hop, if you will, or the interface. So I'm going to basically say 200.0.1.1, right? We said that's going to be the IP of the ISP. So we're 1.012. They're going to be 0.1.1. So we're going to create that route. So now, when I show my routing table, I should see an entry for a static route. Okay, so the key says capital S is static, which we now see. We can see I have a connected route, which was that VLAN 100. Okay, so not a lot going on, right? We're going to have to add another route that essentially kind of points down to VLANs 200 and 300 here at some point in time. Right now, we're not worried about it. We're just going to get basic connectivity up to the internet. So that being said, router 1 should be in a decent spot. Now we're going to hop over to node 11. So let's just give him the host name, node 11, which I know is Not ideal, but let's just match what we've got in the topology. Okay. And then we're playing with Ethernet 0/1. So let's go to E01. Let's no shut him. We're going to say description. We're going to say link to site A. All right. We're going to give him an IP address of 200.0.1.1. And we said that's a /30, which is 252 for the last octet. All right. So now what we should see is an interface that's in an up state, okay, to facing router 1. So let's try to ping router 1. Okay, we can ping. Well, that's good. So it would appear that we just turned up our 1 gig circuit with the ISP. So let's go to router 1 and let's test connectivity to 200.0.1.1. Okay, we can ping. So that's great. Okay, perfect. Okay, now let's add the route for the VLANs on router 1. Okay, since we're using static routing, which is not ideal, it's kind of a pain because you have to not only verify your routes are accurate, but you have to keep track of every single subnet in your environment, and you need to account for reachability amongst all the devices. So again, not the most scalable solution, but for beginners, they usually show you static routes first before you start jumping into protocols. So you kind of understand the idea of the routing table itself and the metrics and administrative distances that are affiliated with the routes. So we know that do show run include route. We know that we've got a quad 0 route pointing to the internet, which is going this way, okay? We need to account for the route that's going down to the switches and the PCs themselves. So what we can do in this particular case is we can build a route, and since we know that, you know, we're using 10.1.0.0/22, we can build one route to essentially engulf all those VLANs. So that's what we're going to do, okay? We're going to say to reach 10.1.0.0/22, okay? Sorry. 22. We're going to go to 10.1.0.11, which is switch 1, okay? Switch 1 has all the VLANs defined on it. We know that we built the connectivity through VLAN 100 to switch 1, which should be .11. We can check that. Yep, so we're right, .11. So all we're saying is to reach anything on this /22 network, just send all the traffic to switch 1. That's all we're saying here. But you can give it a name too, by the way. So you can say name site A subnets, okay? So now when we check the routing table, we can see we've got a static route to the ISP. We've got a second static route. I'm sorry, I messed up the subnet. That's my mistake. Let's modify that. That would have been bad. Do show run include route. Let's take him out for the minute. The 252 should go in the third octet. That's my mistake. Okay. Do show IP route. Yeah, that looks better. So now we've got a /22 static route that goes to switch 1. Okay. So in theory, if we did this right, if we try to ping, switch 1 has VLAN 200. Okay, so now we've got reachability to switch 1's VLAN 200, which, by the way, let me do this too. Let's remove that route real quick. Okay. And then let's do that ping again. So see the difference? So right now, router 1 is directly connected to switch 1 on VLAN 100. It has no idea about VLAN 200, 300, or 400 if we had it built. It doesn't know about it because we didn't tell it about it. And we know that because if we check our routing table, we can see that we know about the 10.10, which is VLAN 100, but we have no idea about 10.11, 10.12, or 10.13. So that's the whole point of this route. So when I put this route back in, okay, as I showed you before, that adds the static route to the table, but what it does is it allows us to have reachability to not only VLAN 200, but we should be able to ping VLAN 300 as well. So we've now built full connectivity from a layer 3 perspective from router 1 to all the VLANs that we have configured in the switches, okay, and we've built our default route out to the ISP. Now the ISP, let's take a peek at him, and this is not the way the routing would be set up in a real life environment. So this is for demonstration purposes at the moment. Like I said, this is just getting us connectivity across. This is not the way you will see it. And there's a blend of public IPs and privates here. This is not the way it would be in the real world. The real life example here is just to kind of demonstrate, like, you know, mimic some kind of ISP connectivity. I'm not mimicking the actual config at the moment. So if we check our routing table here, we know that we can ping router 1, but we're never going to be able to ping any of the private addresses that are beyond router 1 in site A. So let's just do that route now. And again, this is ugly in my opinion because it's not the way it's supposed to be. Let's just build a route for 10.1.0.0. I'll put the 252 in the right place this time. And now we're going to point this one to router 1's Ethernet 01 address, okay? So if we look at that address, it's 200.0.1.2, okay? Actually, we give it a name. We can say Site A subnets, right? So if I check the routing table now, we've got a static route going to the outside interface of router 1, okay, that should give us connectivity down to the switches and the PCs for that matter, right? So if we try to ping VLAN 100 address on router 1, so 10.1.0.1, we can ping. If we try to ping the VLAN 100 address of switch 2, which should be 11, I believe. Switch 1. Oh, there's another variable to this as well. So the other piece to this is where static routing is really a nightmare. So switch 1 has been kind of a layer 2 switch up until this point. Now we're trying to kind of introduce routing to the picture. So you can see I know about all my connected routes, excuse me, but I don't know anything about the internet, right, if you will. So on router 1, if you recall, we configured the static route that pointed all of our traffic to the ISP. So on the switches, let's just build a static route that sends all the traffic to router 1. So you have to do this on a hop by hop basis. So on switch 1, let's go ahead and do IP route. We're going to say anything, okay? So anything that we don't have a more specific route, which is for the default route we're going to define, we're going to send it to router 1's 10.1.0.1 interface, okay? We're just going to call this iNet, okay? Let's do the same thing on switch 2. So it should be exactly the same. right? So from here, since we're here, let's just try to ping 200.0.1.1. Okay, so now we can see that we've got connectivity from switch 2 all the way to the internet, which is perfect, right? If we go to switch 1, we should be able to ping 200.0.1.1, which we can ping there as well. And you can see from a trace route, sorry, I'll show you a quick trick. If we do no IP domain lookup, and then we do a trace route to 200.0.1.1, it should be instantaneous, as opposed to it was trying to look up the domain names or the DNS names. So we can see we're actually routing through router 1, right? Which is what we expect to see, because that's where our layer 2 and layer 3 boundary exists. So once we go from layer 2 to layer 3, essentially it's going to try to route to using that default out to the internet, so we can see the hops at this point. So this is good. So let's go back to node 11. Let's hit the up arrow, and we can see that we've now got connectivity to switch 1, and we should have connectivity all the way back to switch 2, which we do. So we verified the reverse path from all the way from switch 2 there. So let's hop on PC3. These things are so moody. Does this one want to work? Nope. Okay, so just give me 1 second. Let's just stop him. Okay, let's restart them, and then let's see if we can connect. Okay, that's better. Show IP. Okay, so he got 10. No, I can't remember. PC2 hangs off switch 2. Link to PC2 says where descriptions are useful, right? 0, 0. He's in VLAN 200, so he gets 10.1.1.12 because he's PC2. /24, and his gateway is 10.1.1.1. Okay, perfect. Let's try to ping the internet 200.0.1.1. Look at that. So the PC can ping the internet, which is awesome. If we wanted to, this is kind of the theme of this whole series, right? Let's make this a little bit more realistic. So here's another kind of little trick you can do to kind of simulate more of a real life situation. So if this is truly mimicking like an internet service provider, we can create a loopback interface on the router. So we'll just say loopback 0 because it's the first one. Okay, so let's just make interface loopback 0. Let's give it an IP address of the well-known 8888. Okay, so now we've added a real IP address in the mix, right? So if I go back to that PC and I ping 8888, we now have connectivity, which is kind of cool. And it actually should introduce, let me see something here. Trace route. Yeah, there you go. So you can see here in this particular case, we've got another hop at this point. So we've gone from VLAN 200 over to VLAN 100, that's where the routing boundary is, out to the internet to reach 8888. So in this simple topology, you can start to see how the routing table will grow in size and hops will start to increase as we build this thing out. So let's stop here. We've got a great, we're at a good spot because we've got a fully functioning Site A with layer 2 and layer 3 connectivity up and out to the internet. See you guys on the next one.